Hello everyone. So today we are going to talk about the Capacitor Lab, which the purpose of this one is to understand the nature how the capacitor is charging and this is charging, and to evaluate this using our setup for today. So basically, this is a capacitor, simple. It's an electrical component, passive one that stores electrical energy. So for example, if we have here higher potential, let's say it's connected to a power supply. So basically this starts to accumulate some positive charges and this one negative charges. So this one's going to be Q and this one minus Q. So during these two different states, one is a long term or a constant state. This is a constant power supply, okay, injecting some charges inside the capacitor. After a long time, this capacitor is going to have a constant charge, and basically it's going to be open circuit and there's no current is going to go inside again. Okay, so after a long time, after when the time itself it's very big, at this point the charge we are going to have a constant charge, and this is going to have this equation Q equals CV. So the voltage here multiplied by the capacitance of this capacitor, and the amount of charge inside is going to be Q CV. Okay. However, sometimes it is something called transient status, which basically transient state, which basically, if you have here a switch here, and when you close it, at the beginning, the capacitor is going to charge bit by bit, okay, until it becomes fully charged. Okay, same. If this one was fully charged and you open the switch, so basically, you open the switch and you connect this one, for example, to some resistance. So the capacitor has a lot of energy, then basically it starts to discharge all the charges to go inside the resistance. And during this transient state, we use this equation. For example, for discharging, the amount of charge inside the capacitor is equal to the initial amount of charge, the exponential e to the power of minus time over tau. And tau itself is equal to R, the resistance of the circuit, multiplied by the capacitance itself. Okay? So if we need to see it, in general, we have here time and the amount of charge inside the capacitor, you see. So basically, if we started from 0, and we are going to close the switch, so this is going to be exponentially increasing until it reaches this Q, okay, let's say this Q naught, which is equal to CV. Let's this one make it longer. This is Q on the charge. Then this one starts to accumulate and becomes constant, okay, after a long time. And this one basically becomes Q naught, which is equal to CV, the amount of voltage multiplied by the capacitance. Okay? So this, after a long time, becomes this value. If we connect this capacitor to this resistance, R, and we open this switch, so this capacitor is going to discharge all the charges inside the R. So basically, it's going to be like this. It's going to go down until it reaches 0. Okay? So the duration itself to reach, for example, this value, for example, this one was Q naught to reach almost here, 60% of Q naught. This duration is called tau. Okay, and this is the same as well. To reach here, 60%, 63% of Q naught is also kind of down. So this is during DC. After a long time. Okay, it's approximately, let's say, for example, like T, it's more than approximately, let's say, 3 tau or 5 tau. At this point, we're reaching the saturation, the full charge is here. Okay. Then also the capacitor, when this is charging, after a long time, it is going to have a zero charge. Q here is equal to 0. QC here is equal to 0. Okay? So, this is a transient state. Transient. This is constant. This is kind of after a long time a constant. Okay? This is the concept in general about the capacitor. While it's charging and discharging, this equation is for this charge. Okay? This equation for this charge. Okay? Then let's talk about our circuit quickly for the lab itself. So for our lab, we have a power supply, and we're connecting this power supply to a voltmeter. Let's make it the same as the lab manual. Then we have here the first step. We're going to have a resistance of 1 mega ohm connected to the charge sensor. Charge, let's say, charge sensor device here. Okay, they are connected together. Then we have here a switch. It's basically either open or closed. Open like this or closed on the circuit. This is the first step. Okay, the first step, this is closed. We charge it, the charging power supply, and it gives us some values, and we were changing the value of the voltage from 1 volt to 7 volts. Okay, then we have some drawing. The next part, we add here a capacitor. Capacitor here, and the capacitance was 2.2. 0.22 microfarad. Okay. So while the circuit is closed, we are charging. The switch is here. The capacitor these two capacitors start to discharge inside the 1 mega ohm. Okay. And the tau in this case, it's basically going to be C, and this, let's say, it's a charge sensor, and this is a capacitor outside. So tau is equal to C total multiplied by the resistance. So resistance is equal to 1 mega ohm, and the capacitance total is equal to, these two capacitors are in parallel, which means it's equal to C 0.22 microfarad plus CS, because we are in parallel. Okay, so this is C total, this is 1, and this is tau. Remember to not connect this voltage, the voltmeter, to the circuit. Okay, while it's charging. For example, like instead of putting the switch here, you are adding the switch here. this has an internal resistance. It's going to coil up all circuit, and you don't know how much is it. Okay, so don't do this configuration and make a switch here. This is incorrect. Okay, you need to connect this, and the switch should be here at this location. So this is correct. Okay, so let's go for the setup and do the experiment itself. Thank you.